Hello everybody, this is Mr. McNair, and this is a short video on solving special systems. Now, we have solved systems by graphing back in section 5.1, and you know that the solution to a linear system is where the graphs of the lines do what? Intersect. Now, because we're dealing with linear systems, two lines can intersect, or two lines can interact in three different ways. One way that they can interact is that they could cross at one point. All right, something like this would have one solution. Okay, let's write that a little better. Another way that they can interact is this. Two lines might not intersect at all. So since the solution is where the two lines intersect, and these lines don't intersect, this means that they have no solution. Why? Because the lines are parallel. And that's the symbol for parallel. All right. The other way that they can interact is this. Now, you might say, well, Mr. McNair, there's only one line there. And it really does appear that way. But what if I told you that was two lines, one line directly on top of each other? When would those two lines intersect? Everywhere. So this has infinite solutions because they cross, they intersect, they touch at every point on the line. So there's infinite solutions, and those lines are called coinciding lines. Okay? Now, we dealt with the one solution systems before. That's what we dealt with in 5.1, 5.2, and 5.3. Now we're going to talk about specifically the no solution and infinite solutions. Now, here, I give you three examples. One of them has no solutions, one of them has infinite solutions, and one of them has one solution. All right, so they all look pretty much like the same type of problem, but they're going to come out to be different when you're solving them by linear combinations or elimination. So let's deal with example A. Example A, you have negative 8x plus 8y equals negative 6, and 3x minus 3y equals 8. Now, are the variables lined up under each other? Yes. If you add down, does anything automatically eliminate? No. So you need to make something eliminate. Notice that you have a 3x and a negative 8x. What number do both 3 and 8 both go into? What is the least common multiple? 24, right? Now, for something to eliminate, one has to be positive and one has to be negative. They have to be opposites. So what would I need to multiply this negative 8 by to get negative 24? 3. What would I need to multiply this 3 by to get positive 24? 8. So I do that because watch what happens. When I distribute the 3 into the top equation, I have negative 24x plus 24y equals negative 18. And on the bottom, I would get positive 24x minus 24y equals 64. All right, and notice now we have something that cancels out. So when I add down and combine the two, the x's cancel, the y's also cancel. So that leaves you with 0 on the left equals 46 on the right. Now, when does 0 equal 46? It never does. So this means that there are no solutions. And there's no solutions because those two equations represented lines that are parallel. Okay? Next, part B. This one you're going to do the same process. Are the variables lined up here? Yes. If you add down, does anything automatically eliminate? No. Now here, if you take a look at this negative 6x, what cancels with a negative 6x? A positive 6x, right? So what would I need to multiply negative 2 by to get positive 6? Well, I would have to multiply by negative 3. So my top equation I'm going to keep the same. Negative 6x minus 6y equals negative 12. And my new bottom equation, I'm going to distribute this negative 3 to everything, and it will become positive 6x plus 6y equals positive 12. Let's go ahead and add down here. So the x's cancel, the y's cancel, leaving with 0 on the left, equals negative 12 plus 12. Those cancel too. That's also 0. When does 0 equal 0? Always. So that means that there are infinite solutions. These lines, when you graph them, will be right on top of each other because they're really the same line. So these are infinite solutions because the lines are coinciding. Okay? All right. Next one. Again, we're going to solve this like normal. Are the variables lined up? Yes, x's, y's, equal signs are all lined up. If you add down, does anything automatically eliminate? No. Well, let's look at this 6x. What cancels with the 6x? A negative 6x. So what would I need to multiply 3 by to make that negative 6? Negative 2. So the top equation I'm going to keep the same. 6x minus 4y equals negative 6. And the bottom equation will become negative 6x minus 4y equals negative 2. So let's add down. 6x and negative 6x cancel. Negative 4y and negative 4y, be careful, those don't cancel. That's negative 8y. And negative 6 plus negative 2, that's also negative 8. To solve for y, we would divide by negative 8 on both sides, and we will get y equals positive 1. Now that you know that y is positive 1, we could take that y and plug it in to any equation that we have to find the x. I'm going to go ahead and plug my y in to this equation here. So 3x plus 2y, and we know y is 1, equals 1. Let's simplify. 3x plus 2 times 1 is 2, equals 1. Let's solve for x, so we subtract 2 from both sides. So these cancel out, leaving you with 3x equals negative 1. And then we're going to divide by 3 on both sides. So we get x equals negative 1/3. So our answer here is negative 1/3 for x, positive 1 for y. All right, and you should check your answer when you're done. So just to recap, this is a problem that has one solution. And this is the solution here, negative 1/3, 1. Part B had infinite solutions. When you have infinite solutions, you'll end up with one number equals a number, the same number. 0 equals 0, or 5 equals 5. Negative 10 equals negative 10. Here, this was no solutions because you had 0 equals 46, and that's not a true statement. All right, so that was pretty much the whole video, and I hope that this helps. Have a great day.